Okay, hi everyone. We are the civil detectors. Our project is about the GPU benchmarks prediction. Great GPU comes with great responsibility. This is our slogan. So now I will let my student Bailey to start with an introduction to our dataset.
Thank you. Our product is a model that allows the user to input information into the GPU's benchmarks to predict its thermal design power. The GPU benchmarks allow for easy comparison between multiple graphic cards by scoring the performance on a standardized series of tests. This can be useful in many instances, such as buying or building a new PC. Our target value will be thermal design power, or TDP. The TDP is an indicator of maximum amount of heat generated by a computer chip. It's essential a reading that helps determine the power efficiency and performance of components. To create our model, we use thousands of performance test benchmark results. This data set is updated daily on passmark.com with new graphic cards benchmarks. With new performance test v9, the GPU computer score includes the OpenCV GPU test and its calculation, as well as the linear regression model, random forest model, neural network machine learning. And this is our data set. It's where we found most of our information. Okay, now for our data exploration. Why EDA? Exploring data analysis, or EDA, uses existing data to determine the accuracy of predictive model by observing patterns and any possible relationships in the data. Additionally, it identifies the best model for given situations. Size and features. After clearing the data set so that it will be usable in our machine learning model, it has 7 columns and 410 rows. The 7 features are GT3 mark, G2D mark, price, GPU value, test date, and category. The target variable. The TDP refers to the maximum amount of heat a computer chip, including CPU or GPU, is expected to generate under general usage. Our visualization is to further understand the analysis the data set. Several graphs were created. The graph show the correlation between the features, and a variety of graphs were made to show different relationships. Now I put to Genevieve.
EDA charts. The graphs below are provided as visualizations to interpret our GPU data, emphasizing the G3D mark, G2D mark, GPU value, category, and TDP variables. So for our first chart, this histogram focuses on the G3D mark column and counts the number of values within each price range. For our second graph, this scatter plot measures the relationship between the TDP, G3D mark, and category. This scatter plot focuses on the G3D mark and G2D mark to show how these two columns are related. This is a box plot which visualizes the relationship between the category and the TDP. And then for our scatter plot, the X and Y values represent the G3D mark and G2D mark. The color represents the TDP, and the size of each circle represents the price. It basically just captures the relationship between the 4 columns. And then for our density heat map, the X and Y values are the category and GPU value, and the density represents the number of those values. So for our 3D scatter plot, the heat map represents each of the data we include, such as the G3D mark, GPU value, TDP. And the heat map on the right of the screen shows the date of each of the GPU that was tested from 2010 to 2022. And on the left for our categories, if you just click on one of the category sections, and we'll kind of hone in and show that. For our scatter matrix, this scatter matrix visualizes the relationship between all of the numerical data in our data frame. As you can see below, some of the scatter plots have weak correlation and others have stronger correlation. And then for our bubble scatter plot, the price and DD, in addition to showing the price and TDP, this bubble scatter plot shows the category through the color and the GPU value through the size of the bubble. And I'll pass it on to Kathryn.
So this is the data pre-processing. So first we removed all the rows containing missing data labeled NA in the data frame to prevent problems with the machine learning. Then we noticed that the GPU name column had a large number of unique names as seen in the word cloud. We decided to drop this column since it did not help in predicting the TDP value. We also dropped the power performance column since it required the TDP data to be calculated. Next, we converted the category column string features into numerical values. This allowed the category column's data to be used in the machine learning. Finally, we split the data frames columns into X and Y. The TDP column would be the Y value and the rest would be the X value. We also separated the data into test and train data. The train data is 80% of the original data that is fed into the machine learning model to discover any patterns. The other 20%, the test data, is used to test the model's accuracy. Now I'll hand it off to Kiran.
All right, so now we're going to talk about some of the machine learning models that we used. The first one being our linear regression model. Below is an interactive graph that represents two variables, our true label and prediction variables, which separates our raw data from our machine's assumptions, measuring the TDP of each GPU. Which leads us to our next graph, which represents the difference between both our X and Y tested and trained TDP, averaging them with the median using a linear or prediction line. These values will predict the thermal design power of any GPU based off the results created from previous variables, such as the G3D, G2D marks, as well as the GPU's overall value. And next is our random forest model, which is used to create predictions of our GPU by filtering them through multiple decision trees. Now, after the majority vote is made, the decision trees will create an average TDP, which will show the final prediction of the random forest model with the full input process below. Now is another interactive contour graph that represents the true label and the prediction of our data set, separating the raw data and prediction with our random forest analysis. And we also added a feature importance histogram, which rated the significance of each component of the GPU and its relevance to the TDP. And we also included a random forest heat map that provided us another source of interpreting the average TDP through the use of the price GPU variables, as well as the different intensity, showing the cheaper GPU, less value, which essentially means a cheaper and more degraded TDP value.
Okay, next we have our neural network machine learning model. So neural network is a type of machine learning that recreates what happens inside the human brain by inputting information and training the AI to process the information. Then below we have a scatter plot, which predicts the true label. And then next we have our histogram for our neural networks, which is just like the one before it for the random forest, and it shows the feature importance. And then again, the neural network takes inputs and process them through layers, which eventually gives an output. And then below we have a table showing 4 different statistics that we calculated for our linear regression, random forest, and neural network models. So you can see before our grid search CV and after for the random forest and the neural networks.
Okay, so here you can see the working models of it, and if you put in values in each of the places and then press submit, then the AI will try to predict what the TDP will be. So when you scroll down, you get to see that with these specifications, the TDP prediction is around 3,500. So in conclusion, based on the machine learning models we have used for this project, we discovered that linear regression works best for this situation. Even though it's the simplest method, it is the most effective. This product also allows people like buyers and people who build PCs to get a prediction on their GPU's thermal design power after inputting the GPU's other characteristics.
Yeah, that's all for our presentation. I just want to shout out to my students, my team. Basically, they're all beginners in Python, beginners in coding. But anyway, we made it to the end and we had a great presentation. Shout out to my team. Yeah, that's all. Thanks for listening.